First question, I kind of missed it. It's from set 1 in 7.4, and we're being asked to find the first 4 solutions of this function. And I think it's in the interval, whatever. No, it's just the first 4 solutions, actually, starting at 0. So there are 2 ways we're going to do it. I'm going to show you how you can solve this particular one with Desmos, and then we'll do it algebraically. So I'm going to nip over and show you the Desmos version of it first. So here is the function that they were talking about, at least my version of it. And it goes up and it goes down and it kind of flat lines. And superficially, it's very easy to think, well, I won't be able to get 4 answers. And we're starting at 0. So I'm going to zoom in a little bit, which helps. The first answer is easy to miss, but 0 works. And if I go to here, can you see that it's equal to 0 at 0.5? And if I go to here, do you see it's equal to 0 at 1? And if I go here, do you see it's equal to 0 at 1.5? And kind of when you look at the answers, which I'm now going to show you what they look like, it kind of makes sense, right? They're kind of symmetric. Now, the problem with this graph is scale is horrible, right? If you make the thing that high, you really can't see much, especially here. So you have to keep, you know, let's say I was interested in about here. What you have to do is you have to zoom in, right? Quite a bit, you notice, before you can clearly tell that's crossing the x-axis, which is the 0 value. So the 4 answers for that particular question just came out to be starting at 0, 0.5, 1, and 1.5. And if you want to do it algebraically, I'm going to do a different approach. We're trying to solve when is this equal to 0, right? So we're trying to solve 3e to the negative 5t, the sine of 2 pi t equals 0. Well, this entire piece doesn't matter. And the reason it doesn't matter is it's never, ever going to be 0. You can plug any value of t that you like in here, and you will just never get 0. So we only need to focus on what makes that 0. And if you get your unit circle and you look for when is the y coordinate equal to 0, you'll get the answer 0. So far, so good. And if you look for another value, you'll get it happens at pi. And then if you want to get another value, you have to go all the way back to here and get 2 pi. And if you want to find another answer, you have to go all the way around and one more, and you have to get 3 pi. So if I wanted to know the 4 answers, it would be this one and this one, which are in my unit circle. Then back to the beginning, and then a little bit further for the other 2. Now, if you divide this guy, both sides by 2 pi, you get this. If you divide these by 2 pi, you get 0.5. If you divide these guys by 2 pi, t equals 1. And if you divide these by 2 pi, t equals 1.5. You see, it's a perfect match. And that is question 11, which was a kind of leftover from a couple of days ago. Are we okay with that, guy? Could put in Desmos and just read the 4 answers off, or you can kind of just do it the way we did a few moments ago using algebra. If there's no questions, I'm ready to start our final section, at least our homework. We are good. Thumbs up. Like to see it. Why did I do that? We're already in the right place. Put that out the way. I'll put that there. Oh, God. Apologise. Looks like my breakfast made it to the paper. I think that's sausage. Not that that matters. I'm a messy person, aren't I? Okay, so if you want to solve some equations, if you end up looking like this, so we're looking at questions where you get the sine of 3 theta equals nothing 0.1, or the cosine of 4 theta equals 1, or tan of a half theta equals 10, right? Whatever it is you get. Whenever you get an equation where it's a multiple of theta, you're going to have a solution that looks like this. It's going to be theta is whatever the solution you get from your unit circle once you've solved it, and then this bit plus the period of whatever the function you're dealing with, k. So if I'm dealing with these two, the answer will be different than if I'm dealing with these ones, right? Because each one of these has a different period, right? So for instance, in this one here, the answer would be theta equals whatever I got, 2 pi over 3. Okay. This one would be whatever answer you end up getting, plus, what's the 2 pi over 4, that's the period. Okay. On the tangent situation, of course, it's whatever answer you get. When it's a sine and a cosine, isn't it 2 pi over the multiple? But when it's a tangent, isn't it just 1 pi over the multiple? And that's basically what that page is saying. Now I have a whole load of other pages from previous sections. Product to sum to product, double angle, half angle. This last section kind of uses all of them, at least in one question or another. So let me jump right in with our first question, which is going to be number 2, because number 1's too easy to worry about. And we're going to be solving the cosine of 2 theta is equal to 7 times the sine of theta, take away 3. And at the top it says, enter your answers as comma separated lists, and if there's no solution, do no solution. So it could have been a little bit clearer. They want all solutions, right? So that means they want that plus 2 pi k or plus 7 pi k or whatever it is. They want that plus blah, blah stuff k, plus period k, if there is a period, which there will be. First major problem. You can't solve this if you leave them the way they are. If this was cosine theta and this was sine theta, I could rearrange them and eventually get an answer. I wouldn't really change it much. I'd end up with some version of tan, but not this question. If you have a different multiple, in this case 2 theta and 1 theta, you have to rely on changing the double angle into something that looks like this guy. So if you go to the cosine 2 theta guy, there are 3 possible things you could turn it into. This one, and this one. But only one of those 3 is going to play well with the right-hand side. What I mean by playing well is, I mean that it's going to suit it. It's going to have the same things in it. Well, you notice that this has only got sines in it. So I want to pick the one of these that has the sine in it. So the cosine is 1 take away 2 sine squared theta. And I picked that one rather than the other 2 because now at least everybody is a sine. And what we have here is a very mixed up quadratic function. So I am going to add 2 sine squared theta to both sides. And I'm going to subtract 1 from both sides. And now we have everybody together. And I went that direction because I wanted this to be positive. And now we have to factor. We haven't done a lot of these, but we have done some. This is a quadratic, just like 2y squared plus 7y minus 4 is. So I know it's going to be a 2 sine theta, and I know it's going to be a sine theta, because that and that gets me this guy. This number is 4. So I'm looking for things like 4 and 1, 1 and 4, 2 and 2. Right? And the middle term is plus 7. So somehow or other, we have got to come up with a combination that works. Now, if the sine thetas distract you, pretend that it was that question, because maybe you're more comfortable dealing with x's. Okay, so let's pretend for a minute that we were trying to factor that. Can anybody tell me a combination of 4, right? 1 and 4, 4 and 1, or 2 and 2 with various pluses and minuses, right? That is going to give me.
-1 in the front and +4 in the second one.
Would you all agree on that? Now, to check it out, don't you just FOIL it and find if the middle is 7? And you might falsely think, wait a minute, those two numbers only give me +3, that doesn't work. Well, that's the rule that you use when this is x squared. But when this is 2x squared or 3x squared, the only way you can check is something the right answer is by quickly foiling it. Now, so if I FOIL only the x's, I get 8x minus 1. Do you see it works? Now you know that one works. That one works. Do you see how we did it? It's still, you know, it's like 2x squared plus 7x minus 4. So convert everything into signs in this case, factor. And now we are getting close to the end. This factor tells me that if I want the answer to be 0, I have to check what makes that 0. Which in turn, if you add 1, gets me there. And then I'll divide by 2. And if I get an answer that I know is in the unit circle, I should use it. So what guy gives me an x coordinate, or sorry, I should say a y coordinate of a half? The answer, or one of the answers, is pi upon 6. Right, that gets me a y value of a half. What's the other angle in this unit circle who would generate that guy, a half? There's the one that we found, pi upon 6. Where's the other one? Somewhere in this unit circle, there's another angle.
5/6.
I hear you. Great. Now, these are two specific answers, but they want all the answers. Now, technically, this here is going to be a little bit more specific. The period of sine theta is 2 pi. So that's 2 pi because it's period, right? It's 2 pi. Now, the other one, well, it's only going to happen if the sine of theta plus 4 is 0, which means that the sine of theta would equal -4. Are you ever going to get an angle that gives you a sine of theta equal to -4? Is there any solutions you can get out of that? No. So
No.
Forget them, right? If there ain't a solution, they don't matter. Are you comfortable with this process? Because each one's going to be a little bit different. They'll share a lot of things, but they will change as questions progress. Get that one there for a minute. In question 3, we have 2 sine squared theta, take away a cosine of theta, equals 1. And we're being asked to find, all the solutions is kind of standard for this. Now, where's my little list? Oh, I don't have this one written down. I guess I should try and squeeze it in somewhere. No, I don't have them. No good. Sines and cosines, especially if one of them's a square, don't play well together. So I'm not going to be able to just use them the way they are. The only one that really can be changed is sine squared. And I want sine squared to be replaced by something that uses, in this case, cosines. Can anybody remember how to write sine squared in terms of cos squared?
1 minus cos, squared.
Yeah. I know we've done that one, that for the life of me, I can't quite remember where we told you, but I'm 99.9% sure you saw it somewhere. But just to give you a quick recap of what's going on here, there is an identity, probably the only one that everybody remembers, is that one. But if you rearrange this by subtracting a cosine from both sides, you get that relationship. And if you start with this top one and you remove, subtract sine squared from both sides, you get that. So that little bunch is sometimes helpful. You see it's helpful here. That sine squared can be written as 1 minus cos squared. Now this is an equation just like all equations, and we'll tackle it with the same kind of techniques as we typically would do in a quadratic. What do you think I should do next?
Expand the 2 times 1 minus cos squared theta.
Yep. Still pretty ugly, right? Not easy to solve. That's because we've still some more stuff to do. What should I do next?
Move everything from the left side to the right side. They're both positive.
To make it positive, it sounds like a good deal. So add essentially that to both sides. That's how you make that happen. Add a cosine to both sides. That's how you're going to make that happen. And take away a 2 from both sides. That's how you're going to make that happen. Do you now see, I hope you can, a quadratic equation? That's an equals there. I'm going to write it again. And for no reason except my brain likes the variable to be on the left. Right, there. We agree that's that. Right, I'm just writing it that way around. Right, we got a quadratic. Question.
Sorry, the 2, do you subtract that over 2 and then make the 1? Oh wait, did you already do that?
Yeah, we've done that.
Oh, you subtract. Oh, I get it now. Never mind.
Got it? Now, the more you do of factoring trig equations, the easier it gets. So 2 cosine squared means that this is going to be 2 cosine and this is going to be a single cosine. Now, since this number is 1, I don't have any choices. The last time I could have went 1, 4, 4, 1, or 2, 2, but here it's just 1, right? So it's going to be 1 and 1. All I need to do now is figure out who's the plus and who's the minus, and we're done. So which combination, right, would make that become this?
-1 and +1.
check it out. +2, take away 1. For some reason, I've got 2 things there. So if we solve this one, we get 2 cosine theta minus 1 equals 0. Add 1 to both sides. Divide both sides by 2. And since I know that is on the unit circle, let's get our answers. I'm looking for an x coordinate. That's meant to say -1/2, I believe, 1/2 just there. So I'm looking for an x coordinate of 1/2, which ends up being pi/3. I'm also looking for another one. And where is the other one headed? Well, the other one is heading somewhere over here. And it's, let's get that right, somewhere down here. And there it is. What is the period of cosine theta? I know it's a silly question, but I'm asking it anyway. What is the
2
period?
pi.
So don't we do period k, period k? Later on, that question is going to actually be useful. But right now, almost every question you've done is 2 pi, so you're not really paying too much significance to it yet. Well, that guy is 0. So cosine of theta is -1. So I am looking for an x coordinate of -1, and this is one of the situations where there's only one answer, right? Which is there. Of course, plus 2 pi k. And now we have solved it. Are we comfortable with this process? Each one hopefully leads us closer to, yeah, I'm happy with that, whatever. Get those out of the way. Okay, where's, the first one of our questions where we actually have to pay attention to the period of the original question. Right, before I even solve this equation, do you know what it says? The cosine of 3 theta, you see it? Maybe a good idea for you to actually find out what the period is right now, even before you do any of the math. Because after you do the math, it's easy to lose track of this. So the period of cosine 3 theta is 2 pi divided by 3. Are you comfortable about the period then is 2/3 pi? Any answer that we get down here, right? Theta is this or theta is that. Any answer we get, well, you remember it's now going to be plus the period k. So it's going to be plus 2/3 pi k rather than the typical 2 pi, right? So bear that in mind. So we're going to divide both sides by 2. Well, just did that a minute ago. And now a little difference, just a little. 3 theta is going to be that angle, pi/3. And another possibility is that it's going to be 5/3 pi. So far, so good.
Yeah, can't we have 6 answers though?
Yeah. So far, I've only got 2, right? Let's see, how many do they want in this question? Well, they want exact values if it's an exact answer, which it is. So we want these 2 guys first, right? So what I mean by these 2 guys is I want all the solutions. So if you take this guy and you divide him both sides by 3, would you agree you get that? So if 3 theta is this guy, 1 theta is this guy divided by 9. Now if you take this one, you get that guy. Are we comfortable with what I just did there? Uh-oh. You all disappeared for a minute. That was scary. You are here. Right, okay. Maybe I'm just preaching to the choir. Is that pretty obvious? I mean, what I did there. Great. Now, since you want all the answers, it's plus the period K. And the only reason I'm putting a bracket around that is for emphasis. You would normally just write this down. And that's your answer to question A. Now, question B says, give me, did they call it the first six? Yeah, oh, they say, give me, well, I didn't even tell you how many solutions are. So give me the solutions in the range 0 to 2 pi.
I have a question.
Yes.
So it'd be, so just for looking at the 3 on the right hand side, so it's gonna be pi over 3, pi over 9, and then pi over 9 plus 2k pi k, or yeah, 2 pi over 3 k times k. Those
Yeah.
are 3 answers. They're the 6.
Oh, that could well be the
Part
case.
A.
Let's do it then. Yeah.
I'm
Yeah,
talking about
let's
part
do it.
A.
Oh, what, part A? Yeah, these are the general answers,
Okay.
right? So it's the angle you got plus the period times K.
So is the final answer then the pi over 9 plus 2 pi over 3 times k? Or is
I
it all
wouldn't
9
phrase
of
it that
those?
way. I wouldn't phrase it that way, but it is correct. I mean, that's the same thing, if that's what
Right.
you're saying. Yeah, so yes.
So is it
So the
asking,
answer,
so would the question be asking for 6 different answers or just 2?
in this case, they're asking for all solutions. This isn't just one answer. This is that answer plus what you get if you add on 2/3, what if you get if you add on 2 lots of 2/3, what you get if you
Right.
add on forever.
So would you put the pi over 9 plus 2 pi k over 3 for one of the answers, and the other answer would be the 5/9 pi plus the 2 pi k over 3?
Right, let's show you what it would look like in WebAssign. The first answer, comma, that's what your answer would look like in question A.
Okay, so it would just be those last 2 then.
Just those two.
Okay, thank you.
Right, now, if you want to find all the solutions in the range 0 to 2 pi, I guess I'll write that down. Yeah? For part B then, they want to know the solutions. There's a finite number of them in the range 0 to 2 pi. Let's take our general solution, right, which is this one. And the other one, which looks like this. Show you how you would use it. Your first solution is that one. Your next solution is what you get if you add on 1 2/3. Right, just to essentially add on a period. That's really messy to do. Well, I should be able to do it actually. And that's 6. That's going to get you 7. Is it? How many thirds is that going to get you? I'll do it in a calculator. 1/9 plus 2/3 made into a fraction. 7/9. Okay. So first answer, Second answer. Now, that is definitely inside 0 to 2 pi, so I'm okay with that one. Now, if I wanted to get another answer, wouldn't it be pi upon 9 plus 2 lots of that guy? Or you could say just add another 2/3 pi to that and you get the same effect, right? Now, if you do that, the third answer ends up being that plus that plus that is going to get me what? Why do they make my life so hard? 13/9, I believe. And so there's my third answer. Pi upon 9 will work, 7/9 pi will work, 13/9 pi will work. Now I could try for another one, and if I did, it would be pi upon 9 plus 4 lots of this guy, right? And can I just tell you that it's no good? And the reason it's no good is it's too big, right? It's bigger than 2 pi. So I got 3 from here. Now they want 6 altogether. Or actually, I know the answer is 6. They just want all the answers that are in that range, which ends up being 6. So the first one ends up being 5/9 pi. That one. The next one is going to be 5/9 pi add the period. And the next one's going to be 5/9 pi add 2 lots of that guy. And then if I wanted to, I would go 5/9 pi plus 3 lots of that guy and 4 lots and 10 lots until I got an answer that was too big. Actually, that one's no good. It's too big. So this one and this one are the only other 2 that are left. I believe this one is 17/9 pi, and this one, I'm looking at their answer, is 13/9. No, it's 11/9. It's 11/9. So I kept on saying there's 6 solutions, which they are. All the guys with bubbles around it. And now I'm going to do a mistake that's very trivial, and WebAssign is just being awkward. So here is my mistake. I'm writing them all down in the order that I found them. What on earth could be wrong as far as WebAssign is concerned?
It's not in the least to greatest order.
That's it. Would you agree that's not really wrong? Isn't that all the answers are just maybe not in order? That's all. And WebAssign is sometimes a pain in the butt, and it might take that answer all jumbled up, but I've had questions where it didn't take the answer jumbled up. So you might want to look at that as your first place in case it says it's wrong. Don't say, oh God, I don't know how to do it. I'm getting it all wrong. Maybe you should just write them in order. And oh, was that all it was? That was the problem. And we are done. You see, these questions are getting more convoluted, aren't they? Right? Now the period of the original equation, in this case 3 theta, becomes important. Because once you've got that guy, any answer you get, you add on the period k. Not 2 pi k now, but period k. And that's an important distinction. In this question, you're told to round off your answer to 3 decimal places if needed. It may not be needed. And the reason for that is that if the answer is in a unit circle, you don't need that. This question is deceptively, I would say, deceptively easy. Because your temptation is, oh yeah, double angle, turn that into 2 sine theta, cosine theta, and oh, that didn't work. This question is going to be a bit easier than that. The original function was the sine of 2 theta. The sine of 2 theta. What's the period going to be? Sine
Pi?
of 2 theta. Yeah. 2 pi over the multiple pi. So when we get our answers, aren't we going to say plus pi k now, right? That's kind of why I did it here, right? Remember, whatever answers we get is going to be plus pi k. So what do you think I should do to both sides? I'm trying to solve this.
Divide by 2.
You agree that's deceptively easy, right? There wasn't really much in the way of algebra at all. Sine equals a half. I know it says 2 theta, we're not worried about that yet. I just need to find when you get a sine of any kind equal to a half, which is pi upon 6. And where else do you get a sine that is equal to a half? 5/6 pi. Are you comfortable about these two angles? Now, divide by 2, and you get pi upon 12. Divide by 2, and you get 5/12 pi. So far, so good. Now, in question A, they want all the solutions. And that's their way of saying plus the period k. And that is the end of that question. In part B, just like in the previous question, they want you to find the solutions in the interval 0 to 2 pi. So I'll start off with my first answer, which is that one. And then my second answer will be that one. My third answer will be that one, and so on and so on. Why am I going to kill that one and not use it?
Because it's too large.
Yeah. You know, sometimes you get 2 or 3 answers, sometimes you get 5 answers, right? You just keep going until it's too big, right? Now, there's my first one. So my second one's going to look like. That would be the next one, which for the same argument here, I'm not going to do. I think the only thing I need to do is to make this a little bit prettier by combining them. And make this a little bit prettier by combining them. And so we have all our answers. And from smallest, then the next smallest, then the next one after that, and finish with the biggest. And that's what you would write down inside whatever sign. There is a kind of logic to these questions, I agree. I mean, they're not totally weird. Any questions about that one?
I have a question.
Yes.
Is there going to be a relationship between, let's say, like the 2 theta of how many answers are between 0 and 2 pi versus like
Yes.
3 theta?
Yeah. Have
So
you
like
seen
if
a
it's 2, it's gonna be
relationship?
4. If it's 3, then it's 6. And if it's 4, then it's 8.
Yes, with a little caveat. Do you know sometimes you only get one solution, not 2? You know, like cosine theta equals -1, right? You know, that kind of situation.
Yeah.
When that happens, you'll only have one guy. So 2 theta will get you 2 guys and 3 theta will get you 3 guys, right? In that case. But if there's 2 to start with, right? which is happening pretty much all the time, doesn't it, with a few exceptions, then what you said is right. So if I was doing the cosine of 10 theta, God, I hope they never do that to you. Wouldn't there be 20 answers?
Yeah.
10 theta, 20 answers. So that's the pattern, yeah. The only reason I put that little caveat in is, and you know, if you get the cosine, well, let's do one. I'll show you what I'm getting at. Suppose you were solving cosine of 2 theta equals -1. Well, if you go to your unit circle, isn't this one of the few times where there's only one answer to that? And why did I do that? It's pi, right? Agree that's the only one place in the unit circle. So in this case, your answer would be pi upon 2, right? And then plus the period, which is pi k. So in this case, wouldn't there only be one building block angle? Now, what would all the solutions look like? Well, the first one would be pi upon 2. The next one would be pi upon 2 add pi. The next one would be pi upon 2 add 2 pi, but that's too big, so we'll forget about it. And so in this case, you see there's only 2 solutions. Typically, wouldn't you get 4 out of a cosine of 2 theta equals somebody, right? Typically. That makes sense? We're good. Okay. Well, this one is new. And new isn't always good. Oh, last question for today. Don't need any really heavy duty algebra. All I need to do is add 1 to both sides. And that is in my unit circle. And the angle that has a cosine of 1 is the angle 0. And you're not allowed to use 2 pi. So you only got 0. And so if you double both sides, you still get 0. And I should have done my period up here. I need some help here. What is the period of the cosine of theta upon 2?
4 pi.
You nailed it. I've just put in the formula 4 pi. So won't this guy be plus period k? Now nobody writes 0 plus anybody. So in fact, the answer would be that guy. So far, so good. Now, that's part A. Part B wants to know all the solutions in the range 0 to 2 pi, but don't include 2 pi, right? I can handle that. If you want to try this guy out, all you need to do is say the first answer is 0, which it is. The second answer will be 0 plus 4 pi. The next answer would be 0 plus 8 pi. Don't know why I'm writing that, because don't those two get killed off because you can't use them? They're too big, which means there's only one answer in the range 0 to 2 pi. And that is us for today. So